Hey guys, welcome to lesson 6 of chapter 6, and we're going to be solving rational equations here. So these are some of the steps that we're going to go through, and let's go ahead and get started. So here we have fractions. So the first thing is that we're going to multiply everything through by the least common multiple. So think about what the LCM would be in this case. So x, 5, and 6. So hopefully you're seeing in your mind that it's 30x. So I'm going to take each one of these terms and multiply it by 30x. Okay, so when I do that, these x's cancel out. So I'm left with 30 plus, this 5 goes into 30 6 times. So 6x equals, the 6 goes into 30 5 times, 5x. And so now it becomes really simple. So I'm just going to subtract the 6x on both sides, and I get 30 equals negative x. So x equals negative 30. And guys, if you're stuck on a test, make sure that you can plug it back in the original equation. So I have 1 over negative 30 plus 1/5. If you do it by hand or type it in your graph or your calculator, you should end up with 1/6 if you did it correctly. So that is a good way of like checking. Okay, and then also the domain, don't forget that x cannot equal 0 because of that guy down there. Okay, so we're going to do this again. This one's a little bit more difficult, finding the LCM. So in this case, these are connected, so we can't separate those. So we're going to have x times x plus 20. So we're going to multiply everything through by that. So I'm going to go ahead and do that. So when I do that, the x's cancel out. So I have 200 times x plus 20. And then here, these cancel out. So I have plus 300x equals 10. So go ahead and take it from there and see what you get. Hey guys, I just realized that I did not multiply this guy over here by our common denominator, so we can't forget that. Okay, so on the right-hand side, I'm going to get like 10x times x 20. So nothing cancels out there. So I'll rewrite it. Go ahead and finish it and see what you get. Okay, so when you get done with doing all this, you should end up with this. So now I'm just going to simplify it. So my goal is to set everything equal to 0, and I'm probably going to have to factor because I have that x squared. So go ahead and see what you can do with that. Okay, so we ended up, this is on my work here, and we did have to factor it. And so we ended up with x equals 40 and x equals negative 10. And so I'm going to come back up here. This word extraneous, that means that you are going to need to plug it in to your original equation to make sure that nothing weird comes out of it. So for instance, it would be extraneous if I plugged in 40 here and I didn't come up with the answer of 10. It would be like something else. Problems like this, like those are very straightforward. So they're not going to throw extraneous solutions. But sometimes when you get to like the squared problems, like the quadratic problems, sometimes they do weird things. So we definitely need to check it here. So go ahead and check both of those. So just like we did before, I'm going to plug in 40 here and see if it equals 10. And then I'm also going to plug in negative 10 to both places to see if that works as well. Okay, so you should see that they both work. They both ended up as 10 when I plugged them in, so they're both good. Neither of them are extraneous. And so the only thing that we have to do, so let's go up and kind of check out our steps here. So we did not state the domain. And so our domain here is going to be x cannot equal 0 and x cannot equal negative 20. So just don't forget to do that. Okay, on this one, this is very much the same way, except I'm going to go ahead and factor this first. So this is going to be x and then x minus 2. And go ahead and take it away. It's the same exact problem from here on out. Okay, so when you multiplied everything by the LCM, the x's canceled out, the x plus 2's cancel out, and you should be left with this. And so I'm going to turn you loose again. I just want to make sure we're in the same spot. Okay, so you should have gotten x equals 2. And so let's go ahead and talk about the domain. So my domain is x cannot equal 0, x cannot equal 2, and then we've already taken care of that one. That's a combination of both of them. So this poses a problem because my answer was x equals 2, and it can't equal x equals 2. So this is going to be an example of this extraneous solution. So what this means is that there's no solution at all in this case. In this case, like you could have had an extraneous solution of like x equals 40 and you would have still had a solution at -10. But when you only have one solution to begin with, and that's extraneous, and you're going to have no solution. Okay, so go ahead and try this next one. Okay, so this is what your first step should look like. Sorry guys, I wrote that down wrong again. This is what your first step should look like. So from here on out, I'm just going to clean it up and see what happens. Okay, so you should have gotten x equals -3 and x equals 2. So what I'm going to do is I'm going to plug both of these in here. And I have a little space up here, so I'll actually show my work on this. And we'll find out if either of them or both of them are extraneous. Okay, so I just got done checking the -3. And so I combined this, got -1, cleaned this up a bit, and set it equal to -2/5. And so what I did is I just combined like terms here, and I got -2/5. So that's what I was wanting to look for. So I know that -3 is going to work. So now I'm going to try 2. Oh, I was stopped in my tracks because look at the domain here. So x cannot equal 2. And so I automatically know that that's not going to work. I don't even have to show my work there just because of the domain. Okay, so there's 2 different ways to do this. And so the first way I'm going to do this is with the LCD method. So we're going to find the least common denominator of this and this. So I'm going to factor that first. And I'm going to see that this is missing an x plus 2. So I have 6x plus 12 over x squared minus 4 equals x over x squared minus 4. So first thing, let's talk about the domain. So x cannot equal 2, x cannot equal -2. So I know that much. I already know if these are set equal to each other already, then I don't really need to worry about those. I just need to worry about these 2 on top. So 6x plus 12 equals x. So let's see what happens there. I'm going to subtract 6x from both sides. Divide by -5. So x equals -12/5. Okay, so we're going to do this one and see if we end up in the same spot. So when we're going to cross multiply, we're going to multiply these 2 together and these 2 together. Okay, so far I have that. I just wanted to pause a second just to make sure we're on the same page. I'm going to set everything equal to 0 and factor. Okay, so this way is interesting because I ended up with the same -12/5, but I also came up with an extraneous solution. So we know that x cannot equal 2, and so my final answer is going to be -12/5. And that's it, guys.